Alright, today we're going to be talking about some rules for differentiation, which just means like some things you have to, or just rules for when you're taking a derivative. So the first one is the easiest. This one's called the power rule. Most of you probably already know this one. It is if you have if you're taking the derivative, and that's what this symbol means. It just means take the derivative of whatever follows. So if you're taking the derivative of, I'll just do a general term. If you have ax to the n, right, where a is a constant and x, or n is just like any number, this is going to be equal to a times n times x to the n minus 1. So what this means is you just bring down this exponent, multiply it by the coefficient there already is, and then subtract 1. So an example of this was in the last video we took the derivative of x squared. So to use this formula, a would be 1, since this is a 1x squared, n would be 2. So you would just have 2 times x to the n minus 1. And n was 2, so now this is x to the 1, which is just x. So you just start with whatever exponent you have, bring it to the front, and then subtract 1 from that. So that also means if you have the derivative of, let's say, 4x to the 6th, right? This is going to be equal to 24x to the 5th. So you just take whatever's here, bring it down, and multiply it by the coefficient. So you have 6 times 4 is 24, and then subtract 1 from the exponent, and that's your new exponent. And so the power rule works for any function that is in polynomial form. So anything that's a polynomial, you can use the power rule for. The next one we're going to talk about is the product rule. And so this is if you have the product of two functions. So you're taking the derivative of just two functions multiplied by each other, right? This is going to be equal to the derivative of the first one times the second one plus the first one times the derivative of the second one. So if we call this function 1 and 2, a shorthand version of remembering this would be 1 d2 plus 2 d1, because, or in this case we would just switch that. It would be 2 d1 plus 1 d2, because we have the second function, which is our g of x, times the derivative of the first function, which is f of x, added to the first function times the derivative of the second function. And so an example, if you have, let's say 5x plus 2 times x squared minus 3. So, and you're taking the derivative of that. Okay. I don't really remember what I put, but whatever. So if we had something like this, right? We take the derivative of the first one, which would be 5, because if we have the derivative of 5x minus 1, the derivative of 5x is just 5, because this is really 5x to the 1. So if we apply the power rule, you multiply the 1 and the 5, so you get 5 and then subtract 1 from like the existing exponent, which will give you 0. So that'll be 5x to the 0 power, and anything to the 0 is 1, so that's just 5. And then the derivative of negative 1 is just 0, because the derivative of any constant is 0. So we would have 5 for our f prime of x times x squared plus 3, because that is our second function, added to our first function, which is 5x minus 1, times the derivative of the second one, which would be 2x, because we applied the power rule again to that one. And yeah, that's how you do the power rule. You just take the derivative of the first one, multiply it to the second one, and then do the opposite and like add those two. And so another rule that we'll talk about is the quotient rule. And that also is exactly how it sounds. It is if you have two functions divided by each other. So if you have f of x over g of x, this is going to be equal to g of x times f prime of x minus f of x times g prime of x over g of x squared. And if you've run this before, you've probably heard of low d high minus high d low over low low. And so what that means is if we call this our high function and our low function, this would be low, I'm going to just use arrows, low d high minus high d low over low low, which is just low squared. So you take the bottom function, multiply it by the derivative of the top function, and subtract the top function multiplied by the derivative of the bottom function, and put the whole thing over like the denominator of this and square it. So if we did an example of that, we would have, like say we started with sine x over 3x squared, right? So if we had this, we would apply the quotient rule. So we would do the low function multiplied by the derivative of the top. So the low function is 3x squared, and if you remember, the derivative of sine is cosine. So we have 3x squared times cosine x minus the top function, which is sine x, times the derivative of the bottom function, which would be 6x, as we used the power rule for that one, and put the whole thing over the low function squared, which would be this. And by the way, this is not 3x to the fourth. I've seen a lot of people do that. It would actually be 9x to the fourth, since you have to also square the 3. So that is the quotient rule. And the last one we're going to talk about, the last rule for differentiation, is the chain rule. And this one is very, very important to understand. So, for the chain rule, this is where if you have the derivative of one function inside another, so if you have f, the derivative of f of g of x, that's going to be equal to f prime of g of x times g prime of x. So an example of where this would be like a thing is if you had like cosine of 3x to the third, and you're taking the derivative of that, right? You can see you have this function inside of another function. So your g of x would be this 3x cubed, and your f of x would be cosine of x. So if you were doing this, you would leave this like how it is, like you leave this 3x cubed how it is for the first term, and only differentiate the cosine. So the way you would do that is change it to negative sign, because if you remember, the derivative of cosine is negative sign, and leave this 3x cubed the same, right? We never change what is inside the other function for the first part, and then we would multiply it by the derivative of g of x, which would be 9x squared. And that's how you do the chain rule. You just take the derivative of the first one and multiply it by the derivative of the inside. So like a way to remember that is like outside, like the derivative of the outside times the derivative of the inside. And yeah, this one is something you really need to know. And if we just go over real quick some like let's see, just basic let me see, I guess this is still like technically a rule for differentiation. So if you have the derivative of a constant times a function, right, you can bring this constant out to the front. So you would have a times d over dx of f of x. So an example of this could be if you're differentiating 5x to the 1/2, right? You could bring this 5 out to the front and just differentiate x to the 1/2. And the way to do that is by using the power rule. You bring the 5 to the front, or the 1/2 to the front. So you still have this 5 here, and that would be 1/2 times x, and then you subtract 1 from this to the negative 1/2. And that's just equal to 5/2, or 5 over 2 squared x. Since this is negative, you can bring it to the bottom. And another like basic rule that you should know is if you have the derivative of like two functions like added to another, or subtracted, I guess, like plus or minus another function, you can, kind of the same way with limits, you can like differentiate these independently of another. So you just have the derivative of f of x plus or minus the derivative of g of x. This one's kind of intuitive. Like if you're differentiating two functions added and subtracted, you just differentiate them like independently. And one last thing to know is if you have the derivative of any constant, like a, this is always going to be 0 every time. Because if you think about it, this is really like the derivative of that constant times x to the 0, right? Since anything to the 0 is 1. And if we apply the power rule to this, it would be a times 0 times x to the negative 1. And then this is going to make this entire term 0. So that's always going to be 0. So yeah, that's the power rule, the product rule, the quotient rule, chain rule, and then some just basic things you should know about differentiation. And next time we can probably get into the intermediate value theorem and maybe exponential differentiation and like logarithmic differentiation. But for now, you should really know these by heart, because they are very important. Because yeah, you have to be able to take derivatives without really thinking about it. And yeah, with enough practice, this should come pretty easy. So yeah, see you next video.